to the second episode of Tell You, where we tell you STEM and you get the story. Today, we'll be discussing general mathematics with the topic of piecewise functions.
To begin with, what are piecewise functions? Piecewise functions have been studied since the development of calculus, with Cauchy and Weierstrass exploring discontinuities and function limits. These functions play a crucial role in physics and engineering, modeling abrupt changes in electrical circuits and fluid dynamics. In economics, they describe tax brackets. Computer science applies them in graphics and optimization. In education, they help illustrate real-world applications like tax laws.
A piecewise function is a function in which more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is the union of all these smaller domains. Instead of having one formula for all values of x, a piecewise function has different rules depending on the value of x.
To better understand how piecewise functions work, we notate this idea specifically like this. A piecewise function is a function that can be broken into different parts. Specifically, f of x follows Formula 1 if x belongs to domain 1, Formula 2 if x belongs to domain 2, and Formula 3 if x belongs to domain 3.
Let's take a look at this given piecewise function for a clearer structure. It has two different formulas depending on the value of x. F of x equals 2x plus 3 when x is less than 2, 4x minus 2 when x is greater than or equal to 2. Now, let's try and evaluate the function at 2 points, f of 2 and f of negative 2. First, we'll start with f of 2. To find f of 2, we need to determine which formula to use. According to the piecewise function, we use the formula 2x plus 3 when x is less than 2, and 4x minus 2 on the other hand when x is greater than or equal to 2. Since our given x value is 2, we'll use the formula f of x is equal to 4x minus 2. Now, let's try and evaluate it. F of 2 is equal to 4x minus 2. Substitute 2 into the formula, which will give us f of 2 is equal to 4 multiplied to 2 minus 2. 4 multiplied to 2 will give us 8, which will then lead us to f of 2 is equal to 8 minus 2. And after we compute, we will get f of 2 is equal to 6.
Next, let's evaluate f of negative 2. To do this, we again check the piecewise function to determine which formula to use. Since negative 2 is less than 2, we use the formula f of x equals 2x plus 3. Now, let's compute for f of negative 2. F of negative 2 is equal to 2x plus 3. Substitute negative 2 into the formula, and you get f of negative 2 equals 2 times negative 2 plus 3. After simplifying, we get f of negative 2 equals negative 4 plus 3. So, f of negative 2 is equal to negative 1. In conclusion, f of 2 is equal to 6, and f of negative 2 is equal to negative 1.
After learning about the basics of computing for a piecewise function, let's try and apply it into several word problems. For our problem number 1, a user is charged 250 pesos monthly for a particular mobile plan, which includes 200 free text messages. Messages in excess of 200 are charged 1 peso each. Represent the monthly cost of text messaging using the function t of m, where m is the number of messages sent in a month. This function tells us that if you send 200 or fewer messages, you just pay the fixed 250 pesos. But on the other hand, if you send more than 200 messages, you pay 250 pesos plus 1 peso for each extra message beyond 200. So therefore, the piecewise function will be written as this. T of m is equal to 250 if m is greater than 0 and less than or equal to 200. T of m is equal to 250 plus m if m is greater than 200. This means that for the values of m between 0 and 200, the cost of text messaging is a fixed 250 pesos. This means you pay 250 pesos as long as you send 200 or fewer messages. On the other hand, for values of m greater than 200, the cost is 250 pesos plus 1 peso for each additional message beyond 200. So if you send more than 200 messages, you start adding 1 peso per extra message to the base cost of 250 pesos.
Overall, learning about piecewise functions highlights the strong connection between mathematics and real life. From mobile plan costs to transportation fees, different conditions affect pricing and decision-making. Analyzing these scenarios helps us understand how mathematical models apply to everyday situations. Piecewise functions are essential for representing variable-based conditions in real-world applications. By constructing and interpreting them, we can efficiently analyze pricing systems, transportation costs, and similar scenarios. Mastering these functions enhances critical thinking, mathematical reasoning, and decision-making. As we continue learning, we can apply these concepts to more complex problems and improve our problem-solving skills.